Okay, in question number 9, you are given the first equation that has roots alpha, beta, gamma, and delta. You are trying to form a second equation, the rate equation, where the roots are now the power 4. Alpha power 4, beta power 4, gamma power 4, and delta power 4. So in this case, you want to try to first and foremost establish a relationship between the x and the y. X are alpha, beta, gamma, delta. Y is this. So by comparison, you can therefore see that y is actually x power 4. Alright, y is actually x power 4. So now we want to do the replacement. From here, this becomes y plus x plus 1 equals to 0, right? Then what you do from here is, you can say that x is equals to minus 1 minus y. And what you do next from here is, you raise the power 4 on both sides. Raise the power 4 on both sides, okay? On the left hand side, if you raise power 4, this becomes just y. On this side, if you raise power 4, you get this. And so therefore, the equation whose roots are these, right away, it turns out to be, okay, allow me to box up this equation, okay? This equation that you have obtained, and this equation has roots, bear in mind, this new equation, right? It has roots 1, 2, 3, 4. Okay? So, with this equation, now I can do 9b part 1. 9b part 1. Okay. It's too high. Let me rewrite this. Okay, 9b part 1. Here. 9b part 1. In 9b part 1, you are actually asked to find the summation of alpha to power 4. Right. Okay, how do you find the summation of alpha to power 4? Based on this equation, right? Based on this equation, this is the same as find the sum of the roots of this equation, and this is supposed to be minus b over a. So it's minus b over a, so that gives you minus 4. Say again, summation of alpha power 4, it means this plus this plus this plus this. Since these 4 are the roots of this equation, it's as good as find the sum of the roots of this equation, which is minus b over a. Okay, now to do number 9 part 2, right? To do number 9 part 2, which is summation of alpha to power 8, which means it's alpha to power 8 plus beta to power 8 plus gamma to power 8 and plus delta to power 8. Let's see this equation as like this, or this expression as like that. Okay, then I can rewrite this thing as summation of now we have seen this idea a few times before already. This one came from what, you know? This one came from this. You remember? Came from this expression. Just that now the roots are, be very careful. This alpha in this case, right, is actually alpha to power 4, can you see? The alpha is actually alpha to power 4, can you see? Alpha to power 4 and therefore beta to power 4. So I'm actually using the same expression as what we had previously. Then, based on this equation, the summation of this, right, is minus b over a. So how much is minus b over a? In this case, it's minus 4. And then this is 2 c over a, which is 6. 16 minus 12 gives you 4. This is 9 part 2. Now for number 9 part 3. To find the summation of 1 over alpha to the power 4. To find the sum of the reciprocal, right? Remember, it's always negative of the second last over the last. This is part 3. And part 4 is worth the while for you to pause and think for a moment. How are we going to do the part 4? Okay, what I intend to do is, I intend to erase off this part of the board, okay, because I need space here. Erase this part of the board. For the part 4 of number 9, right? Number 9b, you need a certain trick, you know. You need a certain trick. How do you do it? From this equation that I have, I'm going to write like this now. I divide 12 by x first. So I get x cubed plus 1 okay, let me retract. I used the wrong equation. Let me try here. Sorry, I used the wrong equation. Okay, I should be saying from here. Okay, from here. Okay, this equation, right? This equation has this as roots, right? This equation has this as root. So what I intend to do right now is, from this equation, I intend to do this now. I intend to actually divide by y throughout. From this equation, right? I intend to divide throughout by y throughout, so that I get y cubed. Okay, let me see, it's too high now. Oh, is it too high? Let me write this thing down. Y cubed. I divide throughout by y again, plus 4y squared plus 6y plus 3 plus 1 over y equals to 0. Okay, this is to do question part 4. Okay, to do question part 4 of 9b. Okay, to do question part 4 of 9b, firstly, what I did was I divide throughout by y first. Why do I do so? Bear in mind that for this equation, the roots are these, right? For this same equation, which is from here, right? I can also say the roots are the same thing, I know. So what I do is, since these are roots, right, of this equation, what I can do is, I can put in the y as alpha to the power 4. So alpha to the power 4 to the power 3 plus alpha to the power 4 squared plus alpha to the power 4 right. And I can do so for the next root and the next root and the next root, all the roots. So that means the last row I'm going to have is delta power 4 3 plus 4 okay. So what happens is, then from here, I add them up vertically. And you want to note something, no? When I add them up vertically, right? I actually get this now. If I add them up vertically, I get 4 terms, alpha to the power of 12 plus beta to the power of 12 plus gamma to the power of 12 plus delta to the power of 12. So if I add up vertically, this 4 term will give me summation of alpha to the power of 12 plus this next one, right? This next one will be 4 summation alpha to the power of 8 plus 6 summation alpha to the power of 4. Adding up this 3, 3, 3, 3, I get 12 plus summation 1 over alpha to the power of 4 equals to 0. So you can see what's happening right now. Then what I need to do right now is I put in all the numbers that I know of. This is what I intended to find. To get summation of power 8, right, is 9b part 2. 9b part 2 we found just now at this 4. We found that this was 4 just now. This is from 9b part 2 again. Then summation of alpha to the power of 4 is equals to minus 4. This one, right, is actually from 9b part 1. Okay, then plus 12 plus to this one, right, the sum of the reciprocal is part 3 of your number 9, and this is minus 3. So therefore your summation of alpha to the power of 12 is equals to let me see, 16, 28 for F1. I think it's minus 1. I get minus 1. Okay, let me see what's 16, 28, 24, 4. Yeah, I get minus 1, it's correct. It's minus 1. Okay, this minus 1, it's correct. Okay, then that brings us to number 9b part 5. In number 9b part 5, you got summation of alpha power 6. Not power 6, power 16. Okay, to find the summation of alpha power 16, right? For the part 5, part 5. Are you ready? 9b part 5. This b part 5. Okay. I'm going to do number 9b part 5. Okay, just be sure that you can see. Okay, any question for 9b part 4 first? Okay, to do 9b part 5, what's going to happen is, because 1, 2, 3, 4 are the roots of this equation, right? I can just put this number into here, 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 here. I mean, there's nothing else, no variable. Then put this into here, 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 here. This. Tell me what I get. Let me say I put in y as alpha to the power 4 throughout. Next, y as beta to the power 4 throughout. Next, y as gamma to the power 4 throughout. Next, y as delta to the power 4 throughout. And then I add them up vertically. What do you think I'll get? I'll get summation of alpha power 16 plus 4 summation alpha 12 plus 6 summation alpha 8 plus 3 summation alpha 4 plus, okay. If you are following my discussion, what is this number? Okay, if you have been following my discussion, right, you want to ponder for a while before I write down for you what is this number. and this number is actually 4. So once you have found that this is 4, and earlier on you have already found this is minus 1, you have already found summation of alpha 8, which is 4, you have found the summation of alpha power 4, which is minus 4, you plug them in with this number, you can therefore find the summation of alpha power 16. So once again, let me say to you how I got this line. Because this equation has roots 1, 2, 3, 4, you just put a y as this. Putting a y as alpha to the power 4, right? Alpha to the power 4 is alpha to the power 16. Alpha to the power 12, alpha to the power 8, alpha to the power 4. Then do the same thing for next, and next, right? Then add up the 4 equations. Vertically, you will get this line. Okay, and the answer is truly minus 12, right? And that brings us to the end of tutorial 2, question number 9. Okay, in question 10 of tutorial 2, you are first presented with a expression, and this expression, if you were to expand it very quickly, you'll realize that it's just a polynomial of degree 20, right? This is a polynomial of degree 20. And for this polynomial, given that it is factorized so nicely for you, it is not hard to see that this polynomial has roots which are equals to, what are the roots of this polynomial? They are, right, they are minus 1, minus 2, minus 3, all the way until minus 20. These are the roots of this polynomial. For this question, right, the intention here is to find the coefficient of the x to the power of 18. So to this question, you gotta imagine that if you were to expand this, entirely, right, expanding this entirely, you will have, say, x to the power of 20 plus, okay, we do not know what is the coefficient, let's call it p, x power of 19 plus q x to the power of 18 plus, and of course the last one could be the numeral, right? The numeral will be, what's the last one you think? If you were to expand this, the last one, which is just a numeral, which is independent of x, there's no x, just pure number, what do you think is the number? That number will be 20 factorial, right? So I guess imagine yourself expanding this entirely, you will realize that the last term is actually 20 factorial. Your highest power of x, which is x power 20, will have a coefficient of 1 because you take x times x times x times x, will be x power 20. So this is actually the setting of the question, that you have a polynomial, and then this polynomial has roots like this. Okay, now you are required actually to find q. That the intention here is actually to find q. Okay, so I intend to find q by first and foremost finding p first. Okay, how do you find, actually don't need to find p. Okay, I think I do this again. To find q, I intend to actually start off with this expression. Do you remember, if you have to find the sum of the square of the roots, what is it equals to? This will be equals to the sum of the roots square minus 2 summation alpha beta. Okay. For this particular question, because the roots are known to us, these are the roots. So for the left hand side, right, the summation of the square of the roots, if you look carefully, right, it is as good as, okay, maybe don't think for one first. If I ask you to find the summation of alpha square, which means summation of the square of the roots, which means square this plus square this plus square this all the way until here, you find that in summation notation or the sigma notation is actually like this. Right, it's actually like this. Okay, because you actually have -1 bracketed square, -2 bracketed square, and so on and so forth. And then for the next one, right, this becomes summation of r equals to 1 to 20 of minus r squared also. And then you have -2. What is summation of alpha beta? Looking at this one, right? Looking at this one is actually C over A. Remember, the sum of the paired products is actually C, which is Q over A. A is 1. Alright. Now, if you look carefully, this one is as good as just this summation of r equals to 1 to 20 of r squared. Because when you square the minus, it will disappear. And then for this one, right? For this one, it is just as good as, okay, I can pull out the minus because the square becomes just positive. I can write this thing as r squared minus 2q. Okay, so based on this, right? Based on this, you can see that Q therefore is equal to half of this summation of r equals to 1 to 20. Okay, I wrote wrongly. Should be summation of r equals to 1 to 20 of r squared minus right. And then to finish off the question, you must actually recall something that you've learned previously, in your lower years. Do you remember this formula? Summation of r formula is here. Summation of r squared formula is actually here. So you just have to now put in the formula. For this one, it becomes just like this now. 20 over 2, 20 plus 1 whole thing squared minus, okay, this is going to be 20 over 6, 20 plus 1, and then this is going to be 40 plus 1. And then the next thing is, you just need to use a calculator to get the answer. Let me use a calculator, my calculator do it. This is going to be 21,210 squared minus 20 over 6 times 21 times 41 divided by 2. Okay, 20615. So indeed you will get 20615. Like this is how you can actually do question number 10. It's a peculiar question. So when you first attempt it, right, you might be stuck. If you see how I do it, right, it seems quite smooth. It's because I have done this question with students previously, so I know actually the flow. Alright. But I suppose that when you first start off this question, it may take a little while to actually come to this realization. Number one, that the roots are this. It probably didn't occur to you to write down the roots. Number two, it will probably take you a little while before you come to the idea of using this. Right. And then later on, you must actually remember this formula. Based on past experience teaching this question, there were students who used various ways of doing it. Some were quite successful and admit that they go through a long process, right? Some were not. But in any case, if you look at this, a good approach for this question really is like this, right? So with this last question, we have completed the whole of tutorial 2.